So Leetcode problem of the day, and here we bring a solution for your question. In this video, I will be discussing a Leetcode problem of the day, that is sort vowels in a string. I will be discussing this question in 3 major parts, so I highly recommend you to watch this video till end so that you can come across all 3 parts of this question. So without wasting time, let's get started. So what does the question says that we have given a particular string, and what we need to do is we need to convert this string into the new string called as a string t, such that what we need to do is if I come across any of the constant in my string s, I need to keep the constant as it is, which means whatever the position of constant is, I need to keep that position as it is in my new string called as t. But just in case if we come across a vowel, then what we need to do is we need to sort this vowel according to its ASCII value in non-decreasing order, right? Which means in increasing order. So I hope so you understood this question. Now let's try to check what will be the sample input output of this question. So I have taken a one sample string that is called as a Leetcode. So what we can say is we need to generate a new string called as a string t. So I will keep a new string called as a tree, and what they have told us, if you're coming across a constant, keep the position of the constant as it is. So L is the constant because it is not a vowel, so I'll keep it as it is. Now I come across E. Now we know that E is my vowel. Now I need to check, is there any other vowel which has a ASCII value less than E? If you take a small e, it has ASCII value as 101, which is greater than 69. Then T is not my vowel, C is not my vowel, O is my vowel, but again the ASCII value of O is 79, which is greater than my E, and again E has 101, which is greater than my E. Therefore the position of this E will be as it is. Then I come across as E. Then I will check, is there any vowel which has ASCII value less than the given E ASCII value. I will check 101 is my ASCII value of my small e. Then I will check, is there any vowel which has a less than 101? Does it contain E, capital E somewhere? No, but I have the capital O which has a ASCII value as 79. So simply what I will do is I will simply bring this O at the position of small e. Now I come across T. Now I will keep it T as it is simply because it contains a constant. Now I come across C, since it is constant, I will keep it as it is. Now at this O, I have simply swapped this E, right? So I'll simply keep it E as it is. And now we'll check, is there any other vowel in this which is smaller than this particular E? No, because these two E are equal, so there is no any point exchanging in them. So again I come across a D, so D is my constant, so I will keep it as it is. Again I come across E, so I will simply keep it as it is. So this is the new string what we need to generate. What we did is we simply sorted the position of my vowel. The vowel which has the minimum ASCII values, those vowels will come first, than those of which has the higher ASCII values. So I hope so you understood the meaning of the question and the sample of input output. Now let's try to derive the intuition to solve this question. Okay, now let's try to derive the intuition for this question. Now what comes in our brain? Say for example, we have the given number 7, 6, 3, 1, 0, 9. We have given this number, and what we need to find is, if I'm standing over here, I need to find any other number which is smaller than this 7, which is the smallest to the right of that 7. So which data structure comes in our mind in order to find the smallest? The one thing can we do is we can simply sort this number. But the point is, if you try to sort this whole number, all the position of this number will get changed. So sorting will not work. So what will be the second case? Can we say it? We can use a minimum heap, because what does a minimum heap says that minimum heap will always contains a minimum element at the top of it. For example, if I try to convert this into the minimum heap, how does it will look like? So first 0 will commit because 0 is the minimum number, then commit as 1, then commit as 3, then commit as 6, 7, and then 9. Right? This is how my minimum heap will look like, because at the top, every top, what we're having the minimum number. So same intuition we will be working over here. So let's check how it can work for us. So what does a string which we have given us? So we have given the original string, that is S is equal to L capital E small e T C capital O small e and T. So this is the original string which we have given, and what they have asked us, we need to sort these vowels, right? We need to sort this vowel. So simply what I will do is, first of all, I will traverse my whole string and I will check, is it a vowel, is it a vowel, is it a vowel? If it is vowel, right? If vowel, then what we will do is I will simply push it into min heap. Now the question comes, why min heap? Because the min heap will always contain a smaller ASCII value character first at the top of it, right? Therefore we are using the minimum heap. So simply what I will do is I will simply go on traversing my original string from till its length, right? And what I will do is, if it is vowel, right, if is vowel yes of I, if it is vowel, simply push it into my min heap. Simply push it into my min heap. Let my min heap be q. Right, this min heap will be my q. So once I will push it into q, how does it will look like? So which is the minimum ASCII value from this? So e has the minimum ASCII value. So first of all it will contains e. Then o is my minimum value. So o contains o. Then comes e, because e has a greater ASCII value since it is a smaller alphabet. As we discussed over here, e has 69, o has 79, and e has 101. So according to this ASCII value, it gets sorted. Now again, if I try to traverse a string, I will check. Now I come across over here E, L. Let's see, T is my new string. L is not a vowel, so I'll simply keep it as it is. Now I come across E. Now I will check, is there any vowel front of it which has a smaller ASCII value than this given E? No, because E itself is a smaller. So what I will do is I will simply keep my E as it is, and now I will pop that E because I have used it. Now I come across this cap small a. Then I will check, is there any vowel to the right part of this which is smaller than this e? Yes, o is my smaller. So simply what I will do is I will simply keep it capital O and simply I will pop it because I have used it. And what I will do is I will simply swap it with this e. So my e will come over here, right? Then I come across t. Since t is my constant, so I will keep it as it is. Then I come across c. So c is my constant, simply keep it as it is. Then I come across this e because o is not there, right? O is has been stopped with small e. So let me write over here, so small e. Then again I will come across e and keep it as it is because there no any other element which is smaller than this e, right? So I will keep it as it is. So and I will simply erase this. And again I will check, I will come across a d. Since d is my constant, so I will keep it as it is. Then again I come across e. So I don't have anyone to compare, so I'll simply keep it as it is. So this is the original string is converted into the new string such that my vowels in my string has been sorted. We can see it, right? My vowels are inserted. So what we will be using? We will be using a minimum heap. So let's write an algorithm for this. So first step, what we will do is create a min heap. Second step, push all vowels. And third step, again traverse original string, that is s, and compare. What we need to do? Compare each vowel with top of my min heap, and if it is smaller, simply pop it and put it into our new string. So I hope so you understood the intuition behind this question and the meaning of the question. Now let's time to write the code for this.
Now it's time to write the code. So first of all, as we discussed in the description part, we need the minimum heap that is derived using the priority queue. So this is what I have declared in the priority queue, that is the min heap. Now what I will do is I will simply go on traversing each character of my original string and I will check if it is vowel. Right, it is vowel. I'm creating one extra function to avoid the lengthening of the code in a single function. So I'll simply pass it a character of that given string. But before I do pass a character, what I'm doing is I will convert it into the smaller case, that is to lower. Right. Now reason why I'm converting into the lower case, because in question they have mentioned is string contains both larger alphabet as well as a smaller alphabet as well. So if we do not convert it into the lower case, we do need to write the separate condition for both alphabet as well as a smaller alphabet. So it's better to write a condition for the single alphabet rather than writing the condition for both larger as well as a smaller one. If it is vowel, then simply I will push it into my queue. Right. Then if it is not a vowel, then I will not do anything, right? Because what I need to do is I need to sort the vowel in increasing order. The consonant will remain as it is. So at the end, I will simply declare a string called as ns. So before this, I will simply write the function called as is vowel. If it is vowel, it will be character cs. And what I need to do is I will simply return what if ch is equal to a, or if cs is equal to e, or if cs is equal to a high o and group, right? If it is equal to this, can simply to be written true, right? A, E, I, O, and then I will simply declare a string that is answer, that will be the final answer. And again, what I will do is, again, I will go on touching my original string and I will check if it is vowel, right? If it is vowel, tool over. If it is vowel, then what I will do is I will simply pop the element or the character present at the top of my minimum key. So simply what I will do is answer plus q dot top, the character which is present at the top of my key, and simply I will pop it because I have used that character. Otherwise, if it is not a vowel, then it means it is a consonant, and it is mentioned in the question that consonant will remain as it is. So I will push it simply as it is, and at the end what I will do is I will simply return the answer and just check whether it is running fine or not. It got accepted. Let's submit the code. So yes, it got accepted. If we talk about the time complexity, so this will take n log n, because in worst case, if all the characters in my strings are vowel, all the characters will get pushed in my queue. So pushing one element in my minimum heap, it will take log n time. So we have the n elements, so it will take n log n time. So I hope so you understood this video and you really enjoy the way I'm teaching you. Just in case if you are new to the runtime error, to hit the subscribe button so that I can get enough motivated looking to you as a script.